What's up, guys? Welcome to another episode of Rad Talks Tech. Today, I'm going to walk you through a coding challenge, and I'm going to show you how you can ace any coding challenge you're given. I'm going to highlight the key elements that the industry is looking for when they give these coding challenges. So if that interests you, stay tuned. Today's coding challenge is going to be Android based. It's geared towards someone who's looking for a senior level position in the industry as an Android developer or as a lead developer or even as an Android architect. A couple things to know about coding challenges. First off, everyone hates coding challenges. I get it, but they're also an opportunity for you to showcase your talents. And I'm going to show you today what they're actually looking for when they give you these types of coding challenges. Keep in mind, coding challenges are typically written in a vague manner because they're wanting to fish out what your skill set actually is. They want you to go ahead and show the breadth of your knowledge, not necessarily the depth in each part. It's good to have some depth, but you don't have to be full depth on every part of the app. The other thing to note is you don't actually want to give a perfect solution if you're given an open-ended coding challenge. This may sound counterintuitive, but there's no such thing as perfect code to begin with. There may be perfect code for a specific purpose. Depending on that purpose is what determines what would be perfect or not perfect to begin with. For example, there's certain optimizations that make sense with certain applications or certain implementations of apps, whereas others may not make as much sense. You'll see these situations a lot when dealing with something like, do you want to use in Kotlin, do you want to use a filter or find or any of the other operators that you can do on a collection versus writing your own. Sometimes a coding challenge is given where you're just supposed to implement a binary search as opposed to using a built-in search. Fine, that's a whole different story. If you're given an open-ended project where you're supposed to implement an app or some sort of specific functionality, and you weren't told to specifically write your own binary tree or your own binary search or your own any of that stuff, then just go ahead and use the built-in operators that Kotlin gives you, because that helps show that you understand Kotlin and you understand the collections that are already there and the operators you can do on them and how to use them properly. The other reason you don't want to write perfect code is it leaves you an opportunity to talk, and that's a selling point for you on any interview. What I mean is, oftentimes these coding challenges are just one part of the interview process. You've probably already had an initial screening. They just want to know, do you have the technical skills to even move on to the next part of the interview? Or they may have done an entire interview process, and this is the last step where they want to know, do you actually possess those necessary technical skills? So in that case, you're going to write code for a coding challenge. You're going to submit it to them, and they're going to go ahead and critique it. They're going to review your code, they're going to look at it, and they're going to come up with questions. And they want to get into your brain as to how you went about this process, why you chose certain things, why you implemented a certain stack over some other stack, or why you implemented things a certain way as opposed to other ways. And again, there's no perfect solution. So there's certain aspects you actually want to have imperfect in your code in order to be low-hanging fruit. So it's going to draw their attention to it, and they're going to say, why did you do this? You don't want it to be a wrong way of doing it. You just want it to be a simple way of doing it so that it can get them to ask you, hey, why did you do a certain way of implementing this? And then you can go ahead and explain to them, you would have, if this was an actual enterprise application, you would have done it this other way. But considering the time constraints of a coding challenge, and you don't have any more information from the business side of the actual implementation requirements or anything like that, you chose to go ahead and implement it this way. A perfect example of that, I'm actually going to show several of those within this coding challenge I'm going to present to you. A perfect example of that is going to be a repository pattern. You can go through and you can implement an entire database if you wanted to and have this really elegant solution with a database that your repository hits and then checks against network calls and then checks against the database and all of that. But that's a little bit of overkill if you're talking about a coding challenge. So what's even better to do is, instead of using an actual repository, go ahead and just store the data that you're going to store in memory. Maybe even add in a remark on there, something that's going to draw their attention to it that will allow them to ask the question, hey, why did you store it here? Or why didn't you use the repository pattern? And then when you go through and you explain why you went ahead and kept all this in memory, and then you can say something like that the time constraints, it just made more sense for this purpose to go ahead and keep it in memory, because we're only dealing with a small data set. We're only dealing with whatever it is in that case that you're dealing with. So for this specific use case, it makes sense to do this. However, if this were an enterprise solution, I would go ahead and use Room, or I'd use Realm, whatever the stack of your choice is. Room is currently the go-to Google approved answer. So I would say something that, if it were an enterprise solution, I would actually implement this repository or this database aspect using Room, especially since that's what Google recommends doing. And even throw that in there that Google recommends doing. That shows that you know what it is and you made a conscious decision on a coding challenge just to put a smaller, simpler answer out there just for them to see it, and it allows you to talk about it. And then you can go through and you can explain why you would do it the other way. You can even say, historically, in projects I've worked on in the past, we've implemented this in various ways. We have used Room, we have used Realm, we have used SQLite, we've used Enco, we've used all of these other options out there as well. It allows you to just start talking more. That's one of the reasons you actually want to put small imperfections intentionally into your code, because that's the low-hanging fruit. That's going to draw their attention in, and those are the points you're going to be talking about, because interviews are limited in time. So the more you can control the narrative, the better off you are in that interview. You want to control the narrative and you want to control the conversation without them feeling like you're controlling or manipulating them. These are some of the tips and tricks that I've learned in the industry, and I'm going to be sharing them in future episodes, so stay tuned for those. Be sure to subscribe, and I'll be dropping those in an entire series where I'm talking about interviews, specifically in the tech side. These are tips and tricks that I've learned over the last decade plus years that I've been in the industry. I've conducted interviews, I've had to fire people, I've hired people, and I've been through countless interviews myself. So I've learned a lot of tips and tricks about how to land a dream job that you want within the industry and to do it on your terms. Stay tuned for that future episode where I'm going to drip even more information about that. Right now, today, we're going to be talking about the coding challenge portion of an interview. This particular coding challenge is going to cover all aspects of an Android app and how to build them. You might be given a coding challenge where only certain portions of this are relevant, so feel free to take the pieces that are relevant to your situation. However, these are some of the fundamental aspects to every app out there and they're looking for, and I'm going to show you how to break down an app into the elements that are looked for in a coding challenge. And what we're also talking about doing is we're highlighting some of the software engineering principles, especially Solid. That's a big one. If you don't know what Solid is, go back and watch my episode where I talk entirely about Solid, and then come back here and I'm going to show you through this coding challenge. I'm going to show you how Solid actually plays into code and what that actually looks like. Those are also great talking points when you're explaining your code to the interviewers as well. And let's be honest, you can take a programmer seriously if he doesn't have his hoodie up. Come on. I'm kidding. I don't actually like the hoodie up. However, I do like to listen to tunes when I develop. I highly recommend these headphones if you're in the professional setting. These are Bose. I have a link in the description if you want to know more about them. I use these professionally every day. Without further ado, let's jump right in. For this particular coding challenge, you would be presented with something along the lines of, here's an endpoint, write an Android app that pulls down the data, parses it, and displays the information. It could be as simple as that. That's very open-ended, very vague. Or a very common use case is you have a JSON file that you're hitting as the endpoint. You're pulling that down, you're parsing it out, and it's the detail master sort of thing where you have a list. You click on it and it opens up the details. We're going to implement a similar pattern here. Okay. We're going to go ahead and open up Android Studio. We're going to choose an empty compose. We're going to name this coding challenge. Typically, the package name, it might start off with com.example. Go ahead and change that to, it's a very subtle thing. In this case, is com.forefronttechnology Coding Challenge. All right, it's going to go ahead and open up the project to a basic Compose based implementation project. And in this case, it's starting out with a beta version of Compose. I don't like that. I'm going to go ahead and upgrade that real quick. We're going to go to 1.3.1. By the time you're watching this is probably outdated and you'll need to update it to the latest version anyway. Also, let's update the Kotlin version. Let's go to 1.7.10. Let's go ahead and sync. And let's run the app just to make sure we didn't break anything by updating those two dependencies. Okay, we've got an error here. If we scroll up, we can see... all right, so we have a dependency here that's going to require Android version 33. I'm just going to go ahead and make them all 33, compile SDK 33, minimum SDK, and target SDK of 33. That's the latest and greatest right now. By the time you're watching this video, who knows what the latest is. That's why I feel comfortable just go ahead and setting them all to the baseline of 33. Resync it. Cool. Build successful. All right. So now when we run it, all right, we're going to build up the Android emulator. And we see here a blank screen that says, hello, Android. Perfect. Part of the tech stack we're going to use for this project is Hilt. So Hilt is going to handle our dependency injection. Remember, the D in solid stands for dependency inversion principle. We're going to go ahead and implement that using dependency injection, using Hilt for our dependency injection framework. This is also currently the Google approved solution. It's also a great talking point when you're in an interview to talk about Hilt and to give a historical background that you recognize that Dagger first came out as Dagger 1, and some of the downfalls of Dagger 1 was that it used reflection. Then Dagger 2 came out, very complicated, had a huge learning curve within the industry. Real implementation, there was a lot of pain points, a lot of boilerplate you had to write, and that's why you end up with things like Coin out there and a few other competitors, even though Coin technically isn't a dependency injection framework. We'll talk about that on another episode. And finally, Google answered that with Jetpack, and they created Hilt, where they took away the majority of the boilerplate. Hilt is super simple to set up now, and it runs on Dagger, so you still have Dagger. If you need to fall back to a regular Dagger implementation, you can do that as well. And in fact, let me show you how simple it is to set up Hilt. Let's go over to the documentations, the Hilt documentation from developer.android.com. You can see they have here on the screen everything you need to know about how to set up Hilt with sample code ready to go. They're trying to make this as easy for us as they possibly can. And of course, this looks cooler in dark mode. Let me switch that. Okay, so we're just going to copy this line and add it into our project level Gradle file. This is one of the reasons I like to keep the file explorer, the project explorer on the left side in Android mode. You see your Gradle files all stacked on top of each other with an indicator next to it saying project versus module. It's easier to find the Gradle files that way. Let's come back over to the docs. Let's grab the next plugins. All right. And these go in the module level Gradle files. Drop them in here. Now let's grab the dependencies. These also go in the module level Gradle file. Let's sync the project just to make sure that it is implemented correctly. A quick run doesn't hurt either. All right, we're seeing hello Android. That means this is working. We're not using it yet, but it's working. The other part of the tech stack I like to use is Retrofit for my networking calls. There's a lot of other solutions out there right now, including Ktor is another one I'm seeing. Retrofit is a tried and true way at the moment. It's one of the reasons I like to use it. I'm also going to develop this in a clean architecture using solid principles. And in a later episode, I'm going to show you why that's beneficial, because I'll rip out the entire networking layer and drop in a different networking layer and show you can do that in like 15 minutes if set up properly. So let's come on over to the Retrofit documentation. And again, they have a nice clean page here where you can see everything that you need to know about setting it up. And they made it really simple as well to set up. Let's come down to the implementation in the Gradle file. Here we go. Let's copy this line. Come back over to our Gradle. This is the module level Gradle file. Let's drop it in here. Now, I happen to know that 2.9.0 right now is the latest version. Again, when you're watching this, it might be outdated already. to go ahead and update with the latest. Let's go ahead and sync and build. Cool. It's showing hello Android. That's a good thing. This is working. That means we didn't break anything. Now, let me show you here real quick. This is the JSON file that I've thrown up on an AWS S3 bucket. And I'm just going to go ahead and pull this down using Retrofit. And this is the data that we're going to look at. And we're going to parse this and display this information and then do sort of a master detail sort of a thing. We're going to show a grid and we're going to have all this data laid out in a grid with the name and an image, the thumbnail image. When you click on one of these cards, it's going to take us to a detail screen. And it's going to show the full information there. Another opportunity to shine in a coding challenge, because almost every company in the industry right now has a project that is modularized. So they're looking for if you know how to modularize an app as well. Here's a perfect opportunity to showcase your skill set. Let's go up here and change it to project view real quick. Then we click on new module. Be sure to have the Android library selected. And we're going to call this networking. We're going to dump all of the networking tasks into the networking module. Okay. And we're going to need these versions to match the app as well. We're just going to change them to 33. And we're also going to need to pull in Retrofit over here. Luckily, we just brought that into our app module, so we can just copy it from here and paste it over. Let's also bring over Hilt. We may not end up needing Hilt in here, but it doesn't hurt to have it. We can always remove it at the end if we don't use it. Let's go ahead and sync it and run it to make sure we didn't break anything. We're seeing hello Android. We're good to go. Hello Android. Man, Android's really friendly today, isn't it? All right, now we're going to want to actually create an API service. And this is the perfect time to talk about the API service. What we're doing here, again, goes back to dependency injection and inversion control. We're going to go ahead and create an API service that we can inject into the app. So we'll keep the actual networking code here in the networking module, keep it separate, keep it as a library. But we're going to make it injectable in such a way that any one of our view models, it's going to be view models, and the app module are going to be able to consume the API service. This is also a form of abstraction. It's another thing, another key talking point as well. It's a form of abstraction that allows us to be able to separate out the networking aspect from the actual class implementations themselves. The advantage here is by doing this, this would allow us to be able to implement our networking layer using an entirely different stack if we wanted to. It's super easy to come in here and rip it out because it's properly abstracted out and it's injected in. So the implementation in the app module itself, all it sees is the interface, and this is now where we're coding against a contract, which is the interface we're setting up for the API service. All we're doing there is we're saying we need to have certain responses from that. And those responses just have to be something that conforms with our data layer. And then we're going to go ahead and we can map that to whatever's being consumed in the UI layer. And by setting up this abstraction this way, it allows us to be able to rip it out completely, implement something else without touching any of the locations where it's actually being consumed at. It's a huge advantage. It's one of the benefits to modularization, to abstraction, to dependency injection, inversion of control principle, as well as, if done properly, the interface segregation principle, because you're going to only group these API services with only the spots that are actually going to consume them. If you have an enterprise app, you'll actually have multiple API services or multiple endpoints, especially with Retrofit, we have a base URL, and then you'll separate those out. This also ties in with single responsibility principle, because what we're doing here is we're taking the networking layer and saying networking is responsible just for networking. That's it. We're going to change this to an interface. And we're going to be using coroutines, so we're going to want to have this be a suspend function. And we just want something that's going to be able to get all these friends. Remember that JSON file I showed you? Those were That was a JSON file full of friends, and we're going to go ahead and have this return a response, a list of friend response. Now, we don't currently have friend response created, so it's in red. Let's come on over here and let's create a class. Let's create a new package that's going to hold all of our models. Now, we're only going to have one model, but if we were to have multiple models, we would stick them all here in this package. Now let's create a friend response inside of here. Let's make it a data class. Again, this ties back to single responsibility. All this data class is going to be responsible for is just holding the data. We're not going to be putting a bunch of setters and getters in here. We're not going to be putting mappers in here. We're not going to be putting tos and froms. It's just going to be representing the snapshot of the data at that moment. And we want to map this identically to what we're receiving from the server. So we need to have all of the same key values. And this is a perfect opportunity to set up low-hanging fruit. See, I'm going to go ahead and I'm not serializing this. I'm not using serializable, not using anything, not using any of those wonderful features that we have for free in Kotlin. However, what I am using is one of these features that is going to map these exact names across, and in that case, and so this is one of those points where we can show that we understand that there's a better way of doing this, but for simplicity purposes and to put something out there for low-hanging fruit, we can go ahead and drop it in just by doing this. Now we have friend response available. We can go ahead and import it. That's with Option Enter if you're on a Mac. And if you're not on a Mac, you should get a Mac. All right, so this is the API service that we're going to be injecting places, and we're going to be able to use this contract when we need to. This is the interface, not the implementation. But let's go ahead and create an implementation of this. And within the industry, I've seen a couple different ways of doing this. There's two different standards. I've seen where people say default and then the name of the interface, so default API service in this case. Or I've another really common, probably more common, is where you do API service.impl. That stands for API service implementation. The reason why sometimes people want to use the default one is they might have multiple versions of this. So you might have default API service, mock API service, some other variation API service. Whereas if you're doing IMPL, then it's API service IMPL, like implementation, and then mock service IMPL. Like you step out of that paradigm very quickly. All right, we're going to want to use OKHTTP as well. This gives you a great opportunity to talk about caching as well as 304 no change responses from the server. All right, let's implement the functions that are required by this contract from the interface. So we now have get friends in here, but let's leave it as a to-do and not actually write that in just yet. Let's continue setting up the implementation of the API service for Retrofit. We're going to want a private instance of Retrofit. So one of the things to note here is API service is going to be a singleton. So we're going to be injecting around as a singleton. The reason we do this is so that we create this instance once of Retrofit. Retrofit is an expensive instance to create, but once we have it created, we can then just keep it created and keep passing it around without having to recreate it every time. So let's see, retrofit.builder client. We're going to use the OKHTTP client. Base URL, this is where you pass in the base URL. This is also where if you had multiple endpoints that you were hitting, say microservices, but had different base URLs, they're probably grouped differently that way. Then you would have multiple API services and you would inject them. And again, that would go back to the interface segregation principle. So those interfaces would only be grouped together with interfaces that make sense to group together. Let's add a converter factory. This is what allows us to be able to handle the JSON parsing in Retrofit. Now you'll see that that isn't recognized right now as we start typing JSON. Let's head back over to the Retrofit docs. Scroll down a little bit and you'll see here the converters. So they have converters for JSON, Jackson, Moshi, a lot of these. We're going with JSON right now. It's not the recommended one in the industry. If you've been in the industry for a while, you're probably familiar with JSON, and you're probably going to run into a little bit of JSON, but you'll notice that the industry is actually shifting. A lot of people like Moshi right now. So in a future episode, I'm going to show you how easy it is to just rip one out and replace it with another. Because again, we're building this with clean architecture, solid principles in mind, and using proper abstractions. Drop in, we want the versions to be the same, so let's drop in for the JSON converter for Retrofit 2. Go ahead and sync that bad boy. While we're at it, let's go ahead and drop in, okay, HTTP 3 as well. Let's grab that from the documentation. Bam, right here. Sync. Come back into our API service. Now we have access to the JSON converter factory. Let's implement that. Everything is still red because we haven't done the build command yet. When we do that, the red squiggly lines are going to go away. And just like that, red squiggly's gone away. It is now happy with our code. Now we're going to create the actual API functions that we're going to be able to call. And these are functions in an interface. So we're going to go ahead and reference it here. Notice it's in red. That's because we haven't created that file yet. When you take a look at their documentation, see at the top here where you have the different calls. These are within that API functions interface we're about to create. All right, let's come back to the project real quick. And let's go ahead and create an API functions interface. Now, we know that we have a get call that we need to make, and we're going to call friends. It's also a suspend function, get friends, and we're expecting a response of list friend response. Now when we come back over here, we see that we have the API functions available. Let's go ahead and import that as well. All right, let's create a helper class. Let's create an API response. It's going to be a sealed class. What I like to do when dealing with an API or networking layer is I like to be able to build out a sealed class that basically handles a success state, a failure state, any sort of states that you want to capture. Have that built in as a sealed class. And that allows you to have a standard return type for each one of these functions that contains useful data. We're going to make this a generic. This also helps showcase that you know and understand sealed classes. And if you don't, all you have to know about sealed classes is think of them as enums on steroids. That's how a lot of people actually describe them. So we're going to want a success state, and we're going to pass in the actual data. So this data is going to be if we hit an API endpoint, we get a 200 response back, a success. It's going to be a data packet. We're going to go ahead and throw that in as data. So that's just going to be the data package that comes back from the from the server. If it's success, let's go ahead and create a failure state. If it's failure state, we're going to want to know a status code. If it was a 400, a 500, whatever it was, we're going to want to know that. Then there's an exception. Now, this could be a failure within Retrofit, though highly doubt that. It could be a failure within the way we are handling or we are calling something. It's something most likely on our end. So let's go ahead and create that, and we'll go ahead and capture the actual exception that is there as well. Now, another thing I like to do, a helper class, I like to call it, create a safe call. You can go ahead and Google this and you'll find multiple variations of a safe call out there. This is just the form that I'm using today. All right, so safe call, again, generic type. It's going to take in a suspend function lambda. It's going to return a response. And the overall function will give us that API response that we just created. And we'll do this as a single line function. We're going to want to wrap it in a try catch. This is how we're going to capture our exception state. So if something goes wrong here, we're going to be able to capture that exception state that we created, and that's what we're going to return. So API response dot exception, and we can just go ahead and pass in that exception that we're given in the try catch. Now, the try has red squigglies. Let's go ahead and start building that out for every case and take care of the red squiggly lines here. We're going to want val result equals call. So where we handle the actual call. Now we've got a response back, and we're looking for the body. So let's see what the body is from the result. Now we're going to check if the result is successful. So that means we have a 200 back, and we should have some sort of body param, some sort of body data. So in case it is null though, so we're only going to do this if it is not null. And we're going to go ahead and grab, or we're going to pass back a API response, the one we just created, of success. And we're going to go ahead and drop in the body there, because we now know in this case it is successful. The result was successful, and it has a body that is not null. Otherwise, if the body is null, let's go ahead and give a failure. And let's pass back a missing body status code. That's something we're going to internally know, and we'll just call this 999. Okay, so to finish out the red squigglies, we need one else statement. We need to return something. So this is in the case of a failure, because the result is not successful. So we're going to pass back API response failure, and we're going to pass back the status code as well. So this would be a 400, a 500, anything like that. We're just going to directly pass that back. So now we have this nice safe call function that we can call within a view model and reduce the amount of code that we need there. Right, we need to implement the OKHTTP as well. All right, let's go ahead and sync our Gradle files, make sure that we have the necessary dependencies within the networking and the app. All right, now that we have a networking layer built, let's come on over to the app framework, the app module, and start building out the UI, the front end aspect of this.